Hey everybody, this is Gregory from Dapp University. So in this video, I'm going to show you the complete blockchain developer toolkit for 2019 and beyond. And I just put out this massive tutorial that shows you all the tools that you need to know in order to become a blockchain developer. And whether you're brand new to blockchain development or you've been following along with my channel, you're going to want to watch this video because the tools have changed a lot in the past year and I cover a lot of the updates in this video. So before we do that, be sure to subscribe to this channel if you haven't already and click the like button down below. That really helps these videos get found so that more people can learn how to build blockchain technology. This video has a full-length article on my website over at dappuniversity.com. So you can check this article out by visiting dappuniversity.com/articles/blockchain developer toolkit to follow along. And it's a step-by-step article, and it's pretty long, so it covers everything in this video, step-by-step, including code examples and things like that, screenshots. So these are basically the items in the blockchain developer toolkit. First, we're going to set up a blockchain on our computer. Then I'm going to show you how to write smart contracts with the Solidity programming language, and then I'll show you how to write tests against the smart contracts. And then we'll connect to a real live public blockchain network and deploy the smart contracts to it. And then we'll run scripts that you can write code that's run over and over again on a blockchain. Then I'll show you how to connect your web browser to the blockchain and then how to write a JavaScript application that will talk to your smart contracts on the blockchain. And even if you've seen some of my other tutorials, you probably want to watch this one because I cover a lot of changes for 2019 in the blockchain ecosystem like Truffle version 5, Web3.js 1.0, MetaMask, ES6, async await, and things like that. Don't worry if you don't understand what all those things are yet. I will show you in this video. These technologies have changed a lot, and I go over a lot of those changes in this tutorial. All right, enough of that. Let's jump in and start programming. And before you get started, you need to make sure you have Node.js already installed on your computer. You can see if you have Node installed by going into your terminal and typing node-v. You can install Node with a package manager like Homebrew, or you can download it directly from the Node.js website. The first item in the blockchain developer toolkit is a personal blockchain. We're going to use Ganache as our personal blockchain for this tutorial. You can head over to truffleframework.com/Ganache to download it. You can click this download link. And whenever you've downloaded it, make sure you install it. And when you open it, you've got a local blockchain running. So what is Ganache? What is a personal blockchain? Well, a personal blockchain is like a real blockchain network, that's connected to the public or anyone can connect to it, but it runs on a computer. It's, a closed network. And Ganache basically, is a process that runs on a computer that spins up this blockchain and runs on a server. So we can use this to develop smart contracts. We can run tests against it. We can run scripts against the network, develop applications that actually talk to this blockchain. And it's really helpful and it's an invaluable tool in the blockchain developer toolkit. So if you open Ganache, you'll see 10 accounts listed here. These are the addresses to each account on the side, and you'll see these balances. You'll see 100 Ether. This is the Ethereum cryptocurrency that each account has, and is required to pay gas fees in the network and stuff like that. And there's several different pages on here that I'll take you through. This is the mnemonic seed phrase that's used to actually rebuild this wallet. And you'll see some data up here, like the current block, the gas price, gas limit, the network ID, which is how you connect to Ganache, things like that. So this is the accounts page. There's also the blocks page, and this will show you each block on the network. Right now we're at block 0. I guess this is technically the Genesis block. We haven't created any transactions on the network yet, but after you do, you'll probably see this block number increase as you start running tests and deploying smart contracts. We've got the transactions page. Again, we have no transactions created just yet. And we've got the logs page, and this is going to show you all of the server logs, and this is really useful for debugging. So also, you can head to the settings and update your Ganache settings if you want to. One really helpful thing is to change this port number. Some people like to use port 8545. That's what MetaMask defaults to. But I'm going to keep it at 7545 right now. You can also change stuff like the accounts and keys. You can change how many Ether each account gets whenever you start the server. You could add more accounts here if you wanted to. You can actually specify the mnemonic seed phrase. Like, so if you imported your account from MetaMask, you could do that like this. And also don't be too scared if you don't know what all this stuff means yet. I'll explain more of this as we go throughout the tutorial, but if you've seen some of my other tutorials, you might find this interesting because I haven't covered this before. You can also, add some settings for the blockchain, things like that. So again, if you change any of these settings, just make sure you actually click restart in order for them to take into effect. All right, so that's an overview of the Ganache Personal Blockchain Network. Again, this is a really invaluable tool in the Blockchain Developer Toolkit. I highly encourage you to browse around and learn more about Ganache if you haven't already. And we're going to leave Ganache here set up in our project because we're going to need it running in order to develop our project so that I can show you the rest of the tools in the Blockchain Developer Toolkit. The next item in the Blockchain Developer Toolkit is the Truffle Framework. We're going to use the Truffle Framework to develop Ethereum smart contracts with the Solidity programming language. You can install Truffle by going to your terminal and typing npm install-g truffle. And I've updated this tutorial for 2019 to use Truffle version 5, which is actually the latest version of Truffle. So Truffle is a suite of tools that allows us to, develop smart contracts, write tests against smart contracts, deploy smart contracts to the blockchain, manage different blockchain networks. It gives us development console, a script runner, and it also allows us to develop client-side applications inside of our project. So it does a lot, and I'm going to show off all those features in this tutorial. So let's go ahead and create our project. I'm going to go to my terminal and create a new directory. I'll say, call this Blockchain Toolkit. All right, I'm going to go inside of there. And inside this project directory, we're going to create a new Truffle project like this. We'll say Truffle init. This is just the Truffle command that comes with Truffle whenever we installed it earlier. And inside of here, I'm going to go ahead and open this project in Sublime Text. So some people ask me sometimes, what does this subl dot mean? So subl is a symlink for Sublime Text, and dot is just the current directory. All right, so inside of this project, I'm also going to create a package.json file to install some node package dependencies for our project. So I'll create a new file like this. I'll say touch package.json. All right. And inside of here, I'm going to actually just paste in some code. This will be the packages that we need for the project. I won't go through these one by one, save you guys some time. And you can actually find these on the GitHub repository with a link down below, so you don't have to just write all these yourself. So basically, we got some dependencies that are going to be used to develop our client-side application. These dependencies are for writing tests. These are for deploying. This is the server that we're going to use. So there's a lot of stuff in here, but don't worry about it too much. You can just use these to get started. All right, now let's install these dependencies like this. We'll say npm install, and that'll actually pull in everything that's in the package.json file. All right, now that that's finished, I'll clear this out. Let's go ahead and create a new file for the smart contract. We'll say touch, and we'll say contracts, my contract.sol. All right, .sol, that's the extension for the Solidity programming language. And now we can go check out our project directory structure here. So basically, we've got this contracts directory. We've got a migrations contract that actually handles the migrations of the smart contracts to the blockchain. We won't touch this in this tutorial. But here we have this empty file of the smart contract code that we just created from the terminal. All right, so inside here, let's actually write our first smart contract. And I've got a tutorial that kind of goes over this contract a little more in depth if you want to check that out. I actually built it in Remix, but I'm going to build it here inside of Truffle to show you this powerful blockchain developer toolkit. So we'll create this first smart contract like this by declaring the Solidity programming language. We'll say pragma. Solidity. Version, we'll use a caret here. Say 0.4.24. All right. And now we'll actually declare the smart contract with the contract keyword. We'll say contract.mycontract. All right, we'll use some curly braces and we'll open and close these. And the first thing we'll do is create a state variable inside the smart contract. We'll just say a string value. So what this does is it actually creates a state variable that just stores a string. So whenever I say a state variable, that means a variable that belongs to this smart contract. And any variable that belongs to this smart contract is actually stored on the blockchain. So if we change this variable value, we actually update the blockchain state. All right. So we're going to do that. We're going to allow the smart contract to do that. So, but first we'll write a constructor. We'll say structure, and we'll say call this public. And we'll say value equals my value. Okay. So we're actually setting this value when we run this constructor. So the constructor function, like other programming language, is basically the function that gets run whenever this contract is initialized. And this contract is initialized whenever it's actually deployed to the blockchain. So whenever we move the code to the blockchain, this function's run, and this value that we set here is set to the string called my value. Okay? And we're actually going to write some other functions in this smart contract. We'll say function get. All right, let's say public view returns string. And like I said, I've got another tutorial that explains all these kind of like complex modifiers here, like public view and returns. I didn't want this tutorial necessarily to be an in-depth Solidity tutorial. I've got other Solidity tutorials. You can check those out if you want to. I'm mostly just trying to highlight, the Blockchain Developer Toolkit, which is, Truffle's ability to write smart contracts. This is going to be a pretty basic smart contract. We're basically just going to change this value. We're going to be able to read it, and we're going to be able to write it. So right now, we're just going to get the value. We'll say return value. We'll be able to call this function get in order to get this value. And now we'll have a function called set that will allow us to set this value. So value equals value. Okay. So now we have a function to read it and a function to write it. And I'll show you, we'll call these functions actually inside the console, and we run the tests. I want to show you those other tools that are part of the Blockchain Developer Toolkit, like the Truffle console, which is really awesome, and the Truffle script runner, and the Truffle tests. And we can use our smart contract in all of those contexts. But this, first and foremost, is probably the most important tool in the Blockchain Developer Toolkit from a development code standpoint, is the ability to write these smart contracts and deploy them to the blockchain. So here we have this basic smart contract. All right. Now, let's actually compile this smart contract and make sure we didn't make any mistakes. I'll go to the terminal and type truffle, compile. This will actually compile this Solidity smart contract code down to bytecode, and we'll create this big JSON file here in this build contracts directory. It's called an ABI. And an ABI is basically an abstract binary interface that just describes the smart contract from a high level. It tells you, what functions are on the smart contract, things like that, what they respond to. And also shows you the bytecode of the smart contract that gets run on the Ethereum virtual machine. That's what this is right here. So yeah, that's really important, and that's what happens whenever we run truffle compile. It gets compiled down to bytecode, and we get this ABI file. And also, that lets us know that there are no errors in our code. All right, so we've seen two tools in the Blockchain Developer Toolkit so far. We've seen, the Ganache personal blockchain right here they've got running. And we've seen, the Truffle framework and its ability to write smart contract with the Solidity programming language. Now we want to actually put this smart contract on this personal blockchain with Ganache. So we got to do a couple things in order to do that. But that's going to show us how to use some of the other awesome tools like the Truffle console. We'll be able to actually interact with a smart contract and write tests and things like that. So we need to put this smart contract code on the personal blockchain network. And we'll do that by creating a migration file and also update our network settings. So let's update our network settings first. We'll go to this truffle-config.js file here. And I will just clear out all this, and I'll paste in some of this code that you can find in the GitHub repository. All right. So basically all this does is it specifies some networks. It specifies a development network for us that's running on localhost port 7545. That's the same port that we have Ganache running on right here. You can see that. So this is our Ganache network, our personal blockchain. And this is basically just telling us how to run our Solidity compiler. So now that that's configured, we need to actually create a migration file to deploy this smart contract to the blockchain. So that's going to be a script, and we'll create it from our terminal like this. We'll just say, well, actually, let's do it here. I'm going to create a new file from this directory. You could do it from your terminal if you want to. I'm just going to copy this and say, we'll prepend this file with the number 2. We'll say deploy contracts. I'll actually move that on the screen if you haven't seen it. This is number 2 underscore deploy contracts.js. All right. So we need it's important to have the numbering here because this is the order that Truffle knows to run the migrations in. All right, so I just copied the code out of here and pasted it, and we're going to change this. So instead of migrations, we'll call this my contract. So basically what that's doing is just reading the smart contract file out of this file that we created earlier. This is just my contract.sol, right? This is the contract we created here. Or sorry, this one, right? And it's just going to say deploy the smart contract to the blockchain. That's what this code does. All right, so that's pretty easy. Now let's go back to our terminal and deploy the smart contract like this. We'll say truffle migrate. And that's going to run all these migration scripts that we created. The initial migration, which already existed in the Truffle project, and then the one we just created. And that was successful. Now our smart contract should be on the local blockchain, the personal blockchain network that we created with Ganache. Let's test it out. And that's going to bring us to the next item in the Blockchain Developer Toolkit, which is the Truffle console. And the Truffle console is a powerful tool. It's a JavaScript runtime environment that's going to allow us to interact with our smart contracts. So we can open the Truffle console like this. Let's say Truffle console. And inside of here, we can actually get access to our smart contract. We'll say my contract.deployed. All right, it's a function, and we'll say then. This is going to use promises, so we'll pass it a callback function. We'll say instance. We'll say app equals instance. All right. And now we can kind of play around with our smart contract. We'll say app.get. All right, we can see this is the value that we set whenever we initialize the smart contract. If you go inside of here, again, like we just set this value, so here's the default. All right, and we called the get function, which we created here, and it worked. Now let's try to update this value. We'll say app.set, and we'll pass in a new value. See if this function also works. All right. So this right here is a transaction receipt, which means that the transaction went through. We can actually open Ganache and see the transactions page, right? We can see the most recent transaction. I think that's it. Yeah, contract call. So we updated this value, and we see the transaction hash. We can see it in the block and things like that. So you can inspect those if you want to. Now let's actually read that value out. We'll say app.get again. And we can see the new value. So that worked. All right, so this is the Truffle console. It's really cool. I'll show you later. We can actually run this Truffle console like against the test network and things like that, like actually public blockchain networks. For now, we're just connected to our local blockchain network, the personal blockchain we set up. But yeah, that gives you an introduction to this powerful tool in the Blockchain Developer Toolkit. So I'll exit this. And we'll go on to the next item in the Blockchain Developer Toolkit, which is the Truffle test runner. It's really awesome. It allows you to write tests against your smart contracts with JavaScript. And I'll show you how to do that right now. So we'll create a new test file. We'll say touch test my contract.test.js. All right, and we'll open this. Let's see here. We'll just go to the test directory. And inside of here, we're going to create a basic test for this smart contract. So we're going to test that basically it gets initialized with the correct value, like we just saw in the console, and that it will actually allow us to read that value and set that value. So the first thing we're going to do is write these tests in JavaScript in an updated ES6 syntax. And we're going to use stuff like async await, stuff that's just a lot better development practices for 2019. We're going to use the Mocha testing framework and the Chai assertion library to write these tests. So the first thing I'm going to do is require the smart contract at the top of this test like this, like const my contract equals artifacts require, and we'll say my contract sold, just like in the other file. All right, and we'll say contract my contract and accounts. All right, so let me explain this really fast. So contract here is just a function that's going to allow us to write all of our other tests inside of this function. And we can, provide a description, which is the name of the contract. So we're going to, test my contract. And it accepts a callback function. And this callback function is actually going to inject all of the accounts in the network. I'm not sure we're going to use them in this test, but just so you know, they're available. So now we can actually write a test example. And we can say it initializes with the correct values, or value, I should say. And now we're actually going to create an asynchronous function. Oops. So I'll explain this more in a second, but basically this async keyword here is required in order to use the async await pattern in JavaScript. So make sure you create this. And also notice I'm using arrow functions. This is a really nice feature in ES6 and just kind of brings us up to speed with more modern JavaScript development practices. And you'll notice like variable declarations like const rather than var. We'll use const and let as a general rule with these tutorials. So yeah, next inside of here, I'm going to do like const my contract equals await my contract dot deployed. All right. So this is part of the async await pattern. So in my previous tutorials, you might have seen me use like promises inside of here and things like that. So I'm trying to move away from, using promises and things like that and callbacks because it just gets messy. I like this async await pattern better. Basically, this is going to allow us to handle this asynchronous call and wait for it to get finished and assign the value to a variable. All these calls to the smart contract are asynchronous, right, to the blockchain. You have to wait for them to finish. And with JavaScript, we can just use this async await pattern in order to just get the result whenever it's done. So now we've, assigned the contract to a variable. We can say const value equals await my contract get. And we can say assert equal, value equal to my value. All right, so basically that's just going to get the value from the smart contract by calling the get function. We'll wait for that to finish, assign it to value, and make sure that it's equal to my value. All right, so you can run tests with the truffle test runner pretty easily. You just say truffle test, hit enter. Oops, sorry guys, I had a little syntax error there. I actually had this backwards, so my fault. Let's go ahead and run that test again. We'll say truffle test, and we'll wait for it to pass. All right, and it passes. So that's how you run tests with the truffle test runner. This is a really powerful tool in order to, test your smart contracts, ensure that the code is robust. It's really important to test your smart contracts because, the code is immutable. It doesn't change. So you need to make sure it works before you actually deploy it to the blockchain. All right, let's write another test. We'll say it can update the value. All right, we'll say async again, and we'll pass this in. We'll say const my contract is equal to wait my contract deployed, and we'll say my contract set the value again, say new value. All right, and we'll copy this again, and we'll say new value. All right, let's test it and see if it works. All right, and it passes. Okay, guys, so that's the truffle test runner. That's the next tool on the Blockchain Developer Toolkit. Again, it's a super powerful tool that allows you to test your smart contracts, make sure they're robust. You can actually run the truffle test runner against test networks and things like that. It's pretty cool. Yeah, check it out, read more about it, but I wanted to give you the introduction here. All right, so the next item in the Blockchain Developer Toolkit is really just another feature of the Truffle Smart Contract Development Framework. And that tool is the ability to put the smart contract on a public blockchain. So for now, we just, we just deployed the smart contract to our personal blockchain on our machine. But now we actually want to put this on a public blockchain where other people are connected, and we can, we can run tests against the public blockchain. We can use our console to connect to the public blockchain, things like that. It's really awesome. So there's a couple things we need to do in order to make that happen. we need to create a couple files and get a couple dependencies, all right? So the first thing we need to do is get a connection to a public blockchain, and we need a wallet to manage the account, and we need to update the project settings to connect to all these things, okay? So first, let's actually, configure our wallet. We're going to open Ganache, and we're going to head to this page where we see the accounts, and we're going to find this thing called the mnemonic. Right, now this is a mnemonic seed phrase that's basically used to programmatically build the wallet. It's like a big password that'll create these accounts. So this is called an HD wallet or a hierarchical deterministic wallet because it can be built in a predictable fashion from this seed phrase. So we're going to put this seed phrase in our project. We're going to put it in a secret place. We're going to put it in a .env file, which is a place where we can keep secrets, and we're going to read it in our project from that file. So I'll go to my terminal and type touch.env, and inside this file, I'm going to paste this in, put some quotation marks around it, and say a mnemonic. All right. So if you're using Git or anything like that, make sure you add this .env file to your git ignore. You don't want to commit this. This is secret information. You shouldn't share it with anybody. I mean, mine is just development version. I don't care. You can see this. But you shouldn't share yours with anybody else. All right, so now we've created that wallet mnemonic and put it in our env file. The next thing we want to do is actually get a way to connect to the blockchain. Now, in order to connect to the blockchain, we need an Ethereum node, all right? And we could run an Ethereum node a couple of ways. You could basically download something like Geth, and you could actually, install Geth. This is the Go implementation of Ethereum. You could run your own Ethereum node on your machine. It's a lot of hassle. So I say for this tutorial, I'll show you a much easier tool for your blockchain developer toolkit, which is basically to just connect to somebody else's Ethereum node. So that's what Infura is for. Infura is basically an Ethereum node as a service. You can just sign up, which you'll need to do for this tutorial, go through the sign up steps, and obtain your Infura link. That's going to give you a link to an Ethereum node that you can just use for your own purposes with your own API key. So you're going to want to grab your API key whenever you sign up for Infura and import it into your project. And whenever you do that, you'll want to go inside of here and basically store this variable that says, Infura API key equals, you're going to paste in your API key here, like ABCDEFG 1 2 3. I'm not going to put mine in here because I don't want to show you on screen, but you need to paste yours in here in order for this to work. All right, now we want to update our network configuration file to include a public blockchain network. Okay, so we're going to go back to this truffle-config.js file, and we're going to update this file. Like right now, we can only connect to this development network, this personal blockchain that we spun up in this tutorial. But we want to add to this list, and we want to actually create a connection to a public blockchain. So for this tutorial, we're actually going to connect to a test network. We're going to connect to the Kovan test network. So Ethereum has several different test networks. If you open MetaMask, I know we haven't gotten this part of the tutorial yet, but you're probably already familiar with MetaMask. If you're not, we'll go over it in a minute. But MetaMask is basically an Ethereum wallet, and you can see different Ethereum networks here. Like the mainnet is like the mainnet where the real Ether is worth money. The Kovan test network is not worth anything. It's just fake Ether. So we're going to use that for this tutorial so we don't waste money and things like that. All right. So in order to connect to the Kovan test network, I'm going to add some configuration here. And you can feel free to just copy and paste this code from the GitHub repository. Okay. So I'll go over what's going on inside here. First, we're going to require our .env file that we created just a second ago. This has got your Infura API key and your mnemonic seed phrase for the project, for your wallet. And then we're going to use this thing called Truffle HD Wallet Provider, which is going to create a connection for us with a wallet to the blockchain. All right. And we can see this setting here. So this is the setting for the Kovan test network. And this is the development setting we created earlier. And this is the Kovan test network setting. So and we call this Kovan, and we need to specify an Ethereum provider. And we're wrapping this in a function that uses this Truffle HD wallet provider library, passes in the seed phrase in order to rebuild our wallet. And then it gives the Ethereum node URL, which is this Infura link here to the Kovan test network. And it gives your Infura API key. So now we should be able to connect our project to the Kovan test network. Let's try to just see if it worked correctly. I'm going to show you that you can actually run the Truffle console against the public blockchain, which is pretty awesome. So we'll do that like this. We'll say Truffle console -- network. We'll specify the network, and we'll say Kovan, which we just defined in that file. All right. And whenever this opens, we'll actually be able to interact with the Kovan test network. And we can see if it worked correctly like this. We'll say web3.eth.getBlock, say latest. All right. And then console.log. Boom. All right, it worked. So we are successfully connected to the Kovan test network. This is a public blockchain. So I'll explain this code. Basically, Web3 is a library that allows us to communicate with Ethereum through RPC. And I've got a whole series on Web3.js if you want to check that out, to actually show you how to do stuff with Web3 1.0, which is the version we're using in this, which is the version you want to be using if you're trying to become a blockchain developer in 2019, that's for sure. And basically we say get block latest. This is just the latest block on the blockchain. And we log all the information about it. It shows you all the data about the block, the hash, the gas limit, the gas used, things like that. I go through all this stuff in that Web3 series. If you want to check that out, the link's on my website. Probably also in this article if you're following along. Okay, so we are successfully connected to the public blockchain network with our project. The next thing we want to do is actually deploy the smart contracts to the blockchain. So that will be the next tool in our blockchain developer toolkit, is the ability to put these on the test network. So let's do that like this. Basically, we'll need to first get some Ether in our account. If you saw Ganache earlier, these accounts that we created already had Ether on them, but this account by default doesn't just magically have Ether on the Kovan test network. We need to get some. You can get some pretty easily in a chat room. That sounds kind of funny, but we'll say you got to go to this website. It's Gitter, which is a chat room, created by Git, and you can paste in your account here, and this sort of chat bot will automatically send you some fake Ether on the Kovan test network. Now, it's not worth anything in real life, but you'll at least get it in order to have Ether to deploy your smart contract. So take the first account. It's important you do the first one. Take the first account from this list and just copy it. Paste it in the chat room here. All right, and just hit enter. And it will fund your account with some Ether. You might have to wait a second, but it'll do it. And you'll get a confirmation message whenever it happens. So I'm going to close that down. All right. So whenever that's done, then you should be able to actually migrate your smart contract to the network. I'm going to go ahead and give it a try. I'll say truffle migrate -- network Kovan. All right. We'll wait. All right, it worked. That's awesome. So now you've got a smart contract on the Kovan test network. We can actually, take this contract address. We'll copy it. Sorry, I'm going to copy it like this. And I'm actually going to open Etherscan and go to the Kovan version of the Etherscan. This is kovan.etherscan.io. Sorry, kovan.etherscan.io. And I've showed you this a couple times in the tutorial already, but basically this is a block explorer. It allows you to explore the blockchain. This is also, I guess, a tool in the Blockchain Developer Toolkit. So you can paste in your smart contract address here and click search, and you'll see the smart contract that's actually deployed to the blockchain. How awesome is that? So we've got a smart contract that's out there. You can go visit this link and see this contract. Anybody can do it. So I'll close out of that. And now we're actually going to run our Truffle console against the Kovan test network and interact with our smart contract on the public blockchain. So we'll do that again like this, console. And inside of here, we're going to do basically what we just did in the last part of the tutorial. Sorry, I forgot to specify the network. Kovan. So yeah, what we're going to do is basically just connect to the same smart contract that we did earlier, but on a different network. We'll just say, we'll paste in the same code that we did earlier, like this. We'll say my contract.deployed, and then we'll store it as a variable. We'll say contract.get. Oops, sorry, I can't type. All right, my value. We'll do contract set. We'll say new value. All right, we'll wait. This is going to take a second because this stuff just takes a while on the Kovan test network. All right, and it worked. There's our transaction receipt. So now we've got our smart contract on the Kovan test network, and we've actually talked to it. So I will exit out of the console, and there we go. All right, so the next item in the Blockchain Developer Toolkit is the Truffle Test Runner. And this basically is going to allow us to write JavaScript, just script files that we can run against the blockchain over and over again, which is really useful. Like if you've ever had to, whitelist a bunch of accounts in an ICO or something like that over and over again, it's pretty tedious. And having a script runner like this is very helpful. So I'll show you how it works. We'll create a new script in our project directory. We'll say touch. We'll just say script.js. All right. So inside of here, we'll open this script file. And we write all our scripts. We wrap them in this module.exports like this. And say equals function. Say callback. And basically say, this is where we can write our script inside of here. Let's say web3 eth get block. Let's get the latest block, and then we'll log it to the console. This is just like we did in the Truffle console a minute ago, but we'll run it inside of our script. So anything we did inside the console, we could put inside the script to run it over and over again. And we can execute the script like this. We can say Truffle. We can just pass in Truffle and then say exec script.js. All right. Actually, sorry, I forgot. We can do this with a network. So we'll say network Kovan. And we actually want to get the latest block from the Kovan test network, which is a public blockchain. And there we go. See, that's exactly what we did inside the console a minute ago. But we can log it out here with our script. So we don't have to boot up the console and do this over and over and over again. We can actually just get information about the blockchain by running this pre-saved script that we can store for later use. And we can do the same thing with our smart contracts. Like, in our tests, we have this kind of thing where we basically, get the current value. We could do that inside of our test like this. We could basically just require the smart contract inside of here and create a script that just logs out the current value from that smart contract on the Kovan test network. So let's try that again. I expect it to log out the value of the smart contract. It should probably say that it's new value. I think that's what we set in the console. So let's see. Yep, there we go. So we see the new value is logged to the console. So that's the Truffle script runner, guys. That's how you rerun scripts against any public Ethereum network over and over again. It saves you from having to boot up the console, saves you from having to do stuff on Etherscan. It's really, really helpful. So I hope you all enjoyed that part of the series. Let's move on to the next part of the Blockchain Developer Toolkit, which is turning your web browser into a blockchain browser. Now, why is that important? Well, most web browsers right now don't support, connections to blockchains out of the box, right? Basically, you have to install a special browser extension that allows you to talk to the blockchain. And that's what we use MetaMask for, right? That's what I had up earlier in this tutorial. And if you go to the Chrome Web Store and search for MetaMask, or if you're following along with this article on my website, I've got a link to that. You can just click through to it. You can find this resource here. So basically, you'll just want to, yours should say, add to Chrome. I've already got it installed. So once you've added it, you want to make sure it's enabled. You'll see the Fox icon up here. And you'll just click on it, and you'll walk through some setup steps in order to set up your account. So this is an invaluable tool for the blockchain developer toolkit, is the ability to just talk to the Ethereum network inside your web browser. And you're going to need this for the next step in the tutorial, where we connect a client-side application to the blockchain, because you're going to need this Ethereum wallet to use any application. And yeah, so I should mention that. Not only does this not only does this turn your web browser into a Web3 blockchain-enabled browser, but it also gives you a wallet. It stores your account that's connected to the blockchain. Like, you can change the networks, and it knows about every account that you are connected to with. So I'll show you how to do that in the next tutorial. In fact, we'll actually do it right now. Let's go to Ganache, and we will check out the account that we're connected to. We'll actually add it to MetaMask, and we'll track our wallet that way. So if you open Ganache, you go to accounts page, we'll take the first account in the list, and we'll show keys. So this is your private key, right? So you don't want to show this to anybody else. I can show you mine because it's just a dummy account. But you want to copy this. Now, your private key is like your password, right? This is a secret. You don't want to show anybody. But this is your public. This is a representation of your public key. Sorry, it's not your actual public key. But this is your account address. This is safe to show, but your private key is not. So copy that private key. Go back to MetaMask, and we're going to import an account in order to use, our blockchain application in order to use this wallet. We'll go to this multicolored icon here and do import account. And we'll select private key as a type. We'll paste it in here, and we'll click import. All right, there you go. Here's the account that's connected to the blockchain. And you can see the Ether that I just requested earlier in the Kovan chat room. It's got it. All right, so let's go to the next part of the Blockchain Developer Toolkit, which is more about the Truffle framework, and it's the ability to write client-side applications that actually talk to this smart contract on the blockchain. And this is a really awesome feature because it allows you to build full-stack blockchain-based applications. All right, so I'm going to minimize all of this, and we're going to create some new files inside of here. All right, we're going to create a client-side application that does a couple things. Basically, it'll show the account we're connected to. Like, it'll show this account in MetaMask. It'll actually show it on the screen, like this account address here. And the next thing it'll do is it will, let's see here, it'll show the value of the smart contract, the storage value, when we set in the smart contract. And it'll actually have a form that allows us to update the storage value. So we'll be able to see our account, we'll be able to read the data from our smart contract, and we'll be able to write the data to the smart contract as well. All right. So that's what this little client-side application, this JavaScript application, is going to do. So in order to do that, we need to install a new dependency. We'll install one called Light Server. We'll install this with npm. We'll say npm install -g light server. So light server is going to be a web server that's going to serve all the files from our project to a specific directory so that we can create this client-side application in there. All right, so now light server is installed. We actually want to create a configuration file for this server to show it, all the files we want it to serve for the project. So we'll create a new file, say touch, we'll call this bs-config. This is for Browserify, I believe, which is the dependency of light server. So we'll create that. And inside this, I'm just going to paste the configuration from the GitHub repository. You can check out that link in the video description, or if you're following along with the article, it's probably in there too. So yeah, this is a basic configuration that just says, hey, we want to expose the source directory, which we're going to create in a second, and we want to expose this build contracts directory to our web server. And we also want to take everything that's in the node modules directory and create an alias route called vendor so we can import these into our project. All right. So now let's actually create that source directory that I talked about right here. We'll go to the terminal and create, we'll say mk source. Okay. And we'll say touch source. We'll say index.html. This is going to be a markup file that we put all our HTML in for the client-side application. And we'll say touch app.js, which is where we'll write all the JavaScript for the application. Okay. So we'll clear that and we'll go to these directories and we'll go to the index.html file and we'll write some code inside of here. I'm going to go ahead and paste the project code in here. I don't necessarily want to spend all day writing markup in here. I want to just show you how you can write, JavaScript applications, not like take you every step on how to write HTML. So basically inside of here, we've got a Bootstrap-based layout. You can see these dependencies, this Twitter Bootstrap templating framework. This is going to allow us to have some nice UI elements without having to write in CSS ourselves, which is great. And we can see that vendor alias that I mentioned a minute ago. This is coming from node modules, but we aliased the vendor route inside the browserify config file. Or browser sync, sorry. I keep saying browserify and browser sync. I get them mixed up all the time. So the next thing is, we're getting Bootstrap in here with Ajax. That's the dependency. We're pulling in Web3.js to talk to the blockchain. And the truffle contract library out of our node modules directory. And this app.js file, which we just created, which we're about to fill out. Right? And inside of here, we basically have the value. This will be more clear in a minute, but basically here's the value where we're going to show the smart contract value that's stored on the blockchain. Here is the account that we're going to show. We're going to show our account that's connected to the blockchain. And then here is the form that we're going to use to update the smart contract value on the blockchain. And I'll show you all this more in a minute. I want to focus more on the JavaScript code than the HTML code because I think the JavaScript code is more important. All right, so inside this app.js file, we're going to basically create an app. So we'll say app equals, this object, and whenever we load the project, we are going to basically wait for the window to load and initialize it. We're going to call this a init function. Let's go ahead and create that. We'll say init is going to be this first function. And we'll say it's an asynchronous function because we want to use the async await pattern. All right. And we're going to put some code in here. And before we do that, we also want to set some defaults for the project before we fill this out. So basically, this is going to be some default values. You want to specify a Web3 provider, some defaults for the contracts, the account, whether the app is loading or not, and then the current contract, the current smart contract instance. And I'll explain all these in a minute, right? So let's fill out this init function. We want to do several things inside of here. We actually want to fill out, we want to call 3 different functions that we're going to write below. The first is initialize Web3. This is going to initialize our connection to the blockchain. We're going to initialize the smart contracts, and we're going to actually render the application out. So let's fill out those functions as well. All right. So when we initialize Web3, basically we're going to just add the configuration that's specified by MetaMask. Okay. So for 2019, MetaMask has changed. Basically, whenever you go to a website that uses Web3.js, it's going to ask you if you want to connect to the blockchain. It'll have this like confirmation pop up. And this is something that's different from my previous tutorials. This is a recent change. I think it changed like in November of 2018. So you got to change some code in your project in order to make this work. So I'm going to paste in the code that MetaMask actually recommends that we use. So I didn't write this code, myself. I just copied it from MetaMask. So I'll paste this in here, and you can actually see the link where I got this from. I'll pull this down if you're curious. You can read this yourself. But they talk about MetaMask changing. Yeah, feel free to go check this out if you want to. The link is in the code comments. But they show you like how to address this and how to write this code. So I just copied it from this article, basically. All right, so basically what's happening inside of here is this is kind of messy and scary looking. Don't worry about understanding everything inside of here. I know it's kind of overwhelming at the first glance. Basically what's happening is MetaMask and our project are basically going to rely on this notion of a Web3 provider, and that's what it's doing. It's setting a Web3 provider inside your browser. So Web3.js, like I said earlier, is the JavaScript library that allows this client-side application to talk to the blockchain. And basically, all this is doing is connecting our project, our client-side application, to MetaMask, which is going to connect us to the blockchain, okay? So don't worry about this. Just paste this code in your project. It'll work. And read that article if you want to know more about it. So the next thing we want to do actually is initialize our smart contract, okay? So that's this init contracts function that we set here. So inside of here, we're going to require the smart contract that we created, right? This comes from mycontract.json. And this is this smart contract ABI file here, mycontract.json. We're actually pulling this out with the getJSON function. We're using the async await pattern to wait for this to finish, and we're just assigning it to a variable here. And we're going to, kind of just stash this value with this app.contracts, property. And we're going to set the Web3 provider to that contract so it knows where to find it on the blockchain. Okay? All right, the next thing we want to do is actually render the project out. And I will paste this in here. So this is a render function, which is also an asynchronous function because we want to do stuff like async await. Basically, if the app's loading, we don't want it to render again. And we want to tell the app that it's loading. And we want to get the account that we're connected to the blockchain with. So basically, this is going to take the first account that's connected from our Web3 instance, and it's going to set it on our app. And then whenever that's finished, we want to load the smart contract data. And we assign it to a variable here where we say, hey, store the smart contract here, and we're going to assign it to this contract instance in our application. And when that's done, we want to actually get the current value from the smart contract and put it on the page of our application by finding the value and updating the HTML value to this value that we read here. All right, so now that's a lot, really fast. I show you more about some of these things kind of in depth in some of my other tutorials. Feel free to check those out. Like I said, I'm mostly trying to show you how the tools work inside of this tutorial, how the blockchain developer tools work for your toolkit. But yeah, hopefully that gives you an idea. I'm going to actually paste these last two functions inside here. Here's the set function that we're going to use in order to set the value of the smart contract with the form. This is going to have an onSubmit handler. And this is the just set loading function that basically says, hey, is the app loading? And if it is, stuff like right here, we want to prevent the double render, so we just exit. All right. So I know it's a lot really fast. But let's boot up the application and see if it works. So we'll go to our terminal and we'll say, let's look at our package.json file. We said, let's see here. Yeah, our scripts. So the dev script is light server, which starts light server. So we can say npm run dev. And hopefully this will start our project without any problems. All right, so it looks like I had a little error, guys. My fault. I called this bs-config.js. We need to actually rename this to bs-config.json. My fault. I'm sorry, guys. So if you followed along with me, you need to change that to JSON. So let's try that again. All right, and there we go. You can see it worked. All the JavaScript code worked, all the index.html code worked, and we see our smart contract here that's connected to the blockchain. We can see the value here. Here's the value of the stored contract. This is the new value, and we can actually see our account that we're connected to the blockchain with here. We can actually like go to MetaMask and change accounts. I'll actually go like to like the first account on the list here, right? We'll change accounts. We'll refresh the page. We'll see the account has changed. Yeah, that's pretty cool. And now we can actually see like MetaMask is running on the Kovan test network. So that means that this is the value of our smart contract on the Kovan test network. So now I'll show you how to connect your project to Ganache, your personal blockchain. So we'll go back to our project and I'll open a new tab here. This might take me back to the different directory, but I will. No, here we go. And I'll say let's migrate this smart contract to our development blockchain. We'll say truffle migrate network. Say network development. All right, we'll do -- reset in case it's already there. All right, and it worked. So now I'll show you how to connect your personal blockchain to MetaMask in order to use this smart contract for local development. We'll go inside of here and we'll say, port 7545. So I'll actually just copy this. This is the RPC URL to the Ethereum node, basically. So we'll go inside MetaMask and we'll say, go to the networks dropdown and we'll go to a custom RPC. This is the URL for the Ethereum node. And, oops, didn't work. Let's try this again. Let's go to custom RPC. And we'll go settings, all right, RPC URL. And we'll paste in the Ganache RPC here, click save. All right, and it's changed. We can see my value. So we can update a new value. We'll say foobar, set value. And so now, whenever you are, oops, looks like I have insufficient funds. Let's change accounts. So reject. I'm going to change accounts here. Sorry, guys. We'll go to the account I'm actually connected with in Ganache. We'll say account 10. All right. So we'll say foobar. And we'll set the value. And inside of here, we have a MetaMask confirmation pop up. Now, this is really important. Anytime you are, creating a transaction on the blockchain, you need the account to sign it. And that's what we're doing here. So we sign this transaction in order to complete it and click confirm. And there we go. The value is updated. We can refresh this page to see if it changed. And it might take a second, but for development purposes, it'll probably be fast. So let's refresh. Oh. All right, there we go. The value is updated to foobar. So that's it, guys. Congratulations. You have now seen all of the tools in the Blockchain Developer Toolkit for 2019. You created a smart contract. You set up personal blockchain. You've connected to the blockchains with the console. You've run tests. You've done all kinds of stuff. Again, you can follow along with this article on my website over at dappuniversity.com to see how to do this step by step with the code examples, screenshots, things like that. Hope you all like this. Again, you can see my other tutorials on my website about how to build an Ethereum Dapp step by step, how to code your own cryptocurrency on Ethereum. You can sign up for my email list if you want to. You hear from me more. You can actually download my courses for free. You can check that out. It's pretty cool. So yeah, guys, I hope you all like this. Be sure to subscribe to the channel if you haven't already, and click the thumbs up button below. That really helps all these videos get found so that more people can learn how to build blockchain technology. And until next time, thanks for watching Dapp University.